Now, when we save this and reload the page, we're actually going to see an error. It says, uncached data was accessed outside of suspense. This delays the page from rendering. And it specifically calls out our fetch call here as the culprit. So remember when we talked about slow navigations at the beginning of the talk? Well, Next is telling us here that because our new fetch calls are outside of any suspense boundary, they've made our homepage a blocking route. This means that if we were to load it, we'd have to wait for all the data before we see any content from the server. But if we go back to what we just had before we added the fetch call, we just saw everything on the page that didn't depend on those fetches at all. All this UI could have been rendered by the browser before the fetch calls even finished. In fact, before they started, the browser could have already started the work it needed to do to render this page, like fetching the static JavaScript bundles and the style sheets from the server ahead of time. So let's go back, and we're going to fix this error by unblocking our route. And what we're going to do is we're going to move the data fetching code into a new component. We'll call it the standings table. And let's go ahead and render in our tree. And now we'll use suspense to unblock it. Suspense provides a fallback. Usually you provide your own, but for now, let's just use a null fallback. So if we save and reload the page, the error goes away, and we see our static content again. And now, once our fetch calls complete, the data streams in. Pretty cool, right? This is pretty amazing. At first glance, it might look familiar. I mean, haven't we all seen skeleton screens before? And lots of frameworks have APIs for deferring data fetching so that, you know, our whole page isn't blocked by the slowest fetch. So how is this any different? Well, there's something special about this skeleton screen. It's static HTML. That's what that error was all about. Next is guaranteeing that this route can be pre-rendered into static HTML. And if you've worked on Next before, you know that if you can make a route static, it's usually pretty good. It usually ends up in an extremely fast user experience, which is great. Except today, when you make a route static in Next, you can't fetch anything dynamic during the initial request at all. So it's an all or nothing decision, right? If you pre-render a route today, you have to pre-render the whole thing. But pretty much every page has something dynamic. So inevitably, you're going to add some client-side data fetching logic, some new library that's going to complete way after the initial request has already come back. It's going to start waterfalling back and forth between the client and the server. You have to set up API endpoints. You're probably going to bring a library in to make those API endpoints type safe. But here, we didn't do any of that. This page isn't dynamic or static. It's both. In other words, it's partially pre-rendered. And partial pre-rendering is the one mode of rendering for all routes when cache components are enabled. No more choosing between static or dynamic. Every route is partially pre-rendered. And that error that we saw earlier ensures that every new route you add produces some static content that Next can extract in fast initial load. Even if that static content is just some light fallback UI, and most of the page's content is dynamic, it gets the browser to start booting the app instantly. And it doesn't slow down the dynamic data at all, thanks to React's use of server-side streaming. Okay, let's get back to our app. And let's go to the games link up here in the header, which is currently for a foreign. So we'll build out this page. Let's create a new file, a new page module. And we'll fetch the current games, and we'll render the schedule, and then all of the games that are currently playing. And if we save this, again, we'll see an error. That's an old version of the error because we just released Next 16 last night. It says the same thing as before. So let's do the same thing and unblock our route. We're going to extract the dynamic part into a new component, and we'll render it up here in our page. And then we'll wrap it inside of Suspense. And this time we'll add some light fallback UI. So if we save this and take a look, we see our new beautiful skeleton screen. And then once the fetch calls finish, the data streams in. Easy peasy, right? This is what it's like to work with Next under cache components. It's truly dynamic by default. So there's no more implicit caching. We didn't need to add forced dynamic to our page or cache no store to our fetch calls. As long as we're inside a suspense boundary, we can fetch data without any surprises. And those suspense boundaries ensure that every page in our app can serve its static content instantly and prepare the browser for the dynamic content as early as possible. Now, all this seems great to me. Caching in the app router, it's always seems confusing. You know, there's all these conventions you have to know about. There's like 9 different config options. So I do like this new explicit approach. But where are my snappy navs? I want my snappy client navs back. Well, let me show you something. If we reload the games page and then click the link to go home, watch what happens. We see an instant render of the static pre-rendered home page, followed by dynamic data. Let's try it from the other direction. Oh, sorry. So that's where the dynamic data comes in. Now let's try it from this direction. Let's imagine we just refreshed on here and we want to go back to the games page. So we'll see as soon as we click, we get an instant nav to the pre-rendered page, and then the content fills in. So how does this work? Well, the answer is prefetching. Thanks to partial pre-rendering, links will prefetch the static content for the upcoming route by default. And this makes total sense, right? We just saw how the new programming model ensures that each route has some static content, so we know that it's both cheap to fetch and that it won't become stale by the time the user actually clicks the link. So the link tag can just prefetch it in advance, and we can have a snappy client nav, an instant client nav that even though the server was involved originally, by the time we click the nav, it's as if you were in the client doing a client-side navigation. This is awesome. We're able to make use of the browser to get those snappy navs without doing any extra work. We don't have to move any of our data fetching code to the client. We don't need to fork our page component based on whether it's the initial render or our client-side nav.
Yeah.
Instant navigations. But in doing so, they introduce hidden latencies to their apps. Since we're now fetching from the browser, every request introduces a new round trip to your database. And one might be acceptable for one request. When multiple of those have to happen sequentially, that latency stacks up, resulting in much longer loading times overall. So we knew one way to optimize these latencies was to be closer to the database via a server. But we still had the problem of the server not being able to respond up until it finished rendering. So we went back to the drawing board and we bet on server components and streaming. Nextjs was now able to show pieces of the UI as they became ready, without being blocked on the slowest part of the page anymore. But it still didn't feel as instant as a static page. However, we realized we had all the pieces we needed to come up with something new. Something you might have noticed is how binary the choices were. Pages were either fast and stale, or they were fresh but slow. Turns out, the answer was always more composition. And as Sam showed you, Our answer to that was partial pre-rendering and cache components. With a model that allows you to compose both static and dynamic content down to the component level, this allows you to get the best of both worlds, a fast initial UI and optimized data fetching from the server. It's a huge unlock. And I believe it is going to be a big evolution for how you write your Next.js apps. And everything Sam demonstrated earlier just works, whether you're running Next.js on a $5 head-snap VPS or in your cloud platform. Partial pre-rendering works just as intended. But let's see how the cache component model can also help when deploying Next.js on a globally distributed platform. See, if your user is in a different region from your server and data, there's still going to be some latency involved. Next.js can do a lot of things, but we can't make life move faster yet. But as we know from the history of the web, the quickest way of serving content is doing it from a CDN close to your user, right? We do it every day for images, fonts, CSS, JavaScript. Well, because our programming model allows us to extract the initial UI for a page, a platform like Vercel can supercharge Next.js rendering and serve the same UI right from your CDN. And we can also stream in the content from your original server. Cache components not only tells Next.js how to compose rendering over time, it also lets you compose it over space. So, regardless of where your users are on the planet, we now brought latency down to its theoretical minimum. That's the kind of innovation that's at the core of our work at Vercel. We want to build a web framework that works for everyone, but also we want to push the boundary of what's possible on a modern infrastructure. So you might be wondering, does Next.js come with a tutorial on how to do this? Well, not really. We're so focused on building the app router, we didn't spend as much time sharing that philosophy as clearly as we should have. And we heard it loud and clear. Even though lock-in was never our intention, a lot of people claim it was by design. But Next.js has always been open source, and it still drives everything the team does. So it's not just about having our embarrassing PRs in public. It's about building a framework that can be used and supported by everyone to the best of their abilities.
Yeah.
Rising tide lifts all boats. And the ideas we're pushing with Next.js are meant to scale beyond Vercel, even beyond Next.js. So we want you to have the best possible experience with Next.js, regardless of your platform choices. So we've been building something new. The Build Deployment Adapters API. It's a clear and explicit contract between Next.js and the platform that runs it. We're sharing all the primitives that we use to deploy Next.js at scale. And it's all there in a stable and version and documented API. That information was already present when running Next build, right? But there wasn't really any guide on how to enhance Next.js the same way Vercel does. So this API is meant to be a framework for deploying Next.js to its full capacities. We want to provide you with a clear spec, fewer surprises, and hopefully a stronger foundation to invest on. Another piece of the puzzle is, well, once you build your adapters, how do you verify that they actually work as intended? Well, we're also sharing the same test suite that we use to validate all Next.js features on Vercel. And our goal is to create transparency for our users, so that when they adopt a new platform, they can verify that Next.js works well. And this also helps us identify which area of the ecosystem we can better help on. We didn't do this alone. Earlier this year, we created a working group with contributors from AWS, Cloudflare, Firebase, Netlify, and OpenNext. We gathered the pain points they had when hosting Next.js, and from there we crafted an RFC and refined the design together. And so what I've announced today is a result of that collaboration. With Nextjs 16, deployment adapters shipped in alpha. And we want your feedback as we migrate the ecosystem gradually. We're also using the same API on Vercel with our own adapter. We want to play fair, and with the same rules we're imposing to our partners. Our goal is to use this as the foundation for a more collaborative Nextjs, one where the ecosystem benefits from all the work we continue to do at Vercel. And so to everyone in our working group, thank you for your time, for your feedback, and all the engineering hours you've invested into making this possible. If you're a platform provider who wants to better support Next.js, we'd love to work with you. So today, we talked about 3 long-term bets for Next.js. TurboPack, which was our bet on incrementality and a better developer experience. Cache components, our bet on a programming model that unlocks new levels of performance with composition. And the deployment adapters API, which was our bet on an open Next.js and one that scales beyond Vercel. These ideas have been in motion for years, and they're finally here. Next.js is able to TurboPack as the default, Cache components as an opt-in, and we'll be sharing guides, examples, and migration path to help you make the most of them. I'm incredibly proud of the work the team has done for this release, and I'm extremely excited to see what you will build next. Thank you.
Amazing.
Everybody, thank you. Conference and this release feels like an inflection point for the framework, for the ecosystem, and for the future of coding. We talked a lot about the future of coding with LLMs and agents. So we decided to bring something even better than agents. The people behind the agents. So we'll have
Are we gonna have a talk on like ChatCN
from Vercel, who's working on V0, Fawad from OpenAI working on Codex, Matten from Factory AI working on Droid, and Swix from Latent Space, who's going to moderate this panel, and they're all going to talk about this future that's coming, and in many ways is here today. So let's give it up for them, and thank you again.
That is good. You're welcome. Nice. All right. Welcome to the Future of AI Coding panel. Thank you for reading the memo that you have to wear all black. Okay, so I do want to cover a little bit of introductions. I know each of you in different ways, but maybe the audience fully doesn't quite. Matan, why don't you go first? What are you proudest of? Like, what is Factory's position to like the broader world in AI coding?
Yeah, so at Factory, our mission is to bring autonomy to software engineering. And that means more concretely, we have built end-to-end software development agents called droids. They don't just focus on the coding itself, but really the entire end-to-end software development lifecycle. So things like documentation, testing, review, kind of all the ugly parts so that you can also do the more fun parts like the coding itself. And for the parts of the coding you don't want to do, you can also have the droids do that. So we build droids.
Build droids. And OpenAI obviously needs no introduction, but your role on the Codex team, I saw you pop up on the Codex video. That's how I knew there was you working on it. But how do you think about Codex these days, since it's expanded a lot?
Yeah, so earlier this year, we launched our first coding agent, which I worked on Codex CLI, bringing the power of our reasoning models into people's computers. Then we released Codex Cloud, where you could actually distribute and kind of delegate those tasks to work in the cloud. And over the last some odd months, we've been unifying these experiences so they work as seamlessly as possible. So a lot of our focus is around how do we make the fundamentals, the primitives, as useful as possible. We just released at Dev Day Codex SDK. So I think one of the key directions we've been seeing is not just using coding or code executing agents for coding, but also for general purpose tasks. And so whether it was ChatGPT agent, which I worked on earlier this year, that actually executes code in the background to accomplish some tasks, but starting to enable our developers to build on top of not just the reasoning models, but also things like sandboxing and all the other primitives that we built into Codex.
Awesome. V0?
Yeah, the goal of V0 is to enable developers to do preview-driven agentic programming. So today, when you build web apps, you probably have an agent open, your IDE open, so some kind of code, and then a preview of what you're actually building. Usually you're running dev server. With V0, our goal is to allow you to just have an agent running and directly prompt against your running app. And that's how we think the future of DX is gonna pan out.
Okay, awesome. And everyone has different like surface areas in which to access your coding agents. So I think one of the things that we kind of want to kick off with is how important is local versus cloud? You started local, went cloud. You started cloud, went local. You're cloud only for now. What's the split? Is everyone just going to merge eventually?
Yeah, so maybe I can start there. So I think at the end of the day, the point of these agents is that they are as helpful as possible, and they have a very similar silhouette to that of a human that you might work with. And you don't have local humans and remote humans that are like somehow, this one only works in this environment, this one only works in that environment. Generally, humans can be helpful whether you're in a meeting with them and you come up with an idea, or you're sitting like shoulder to shoulder at a computer. So I guess asymptotically, these need to become the same, but I think in the short term, remote is typically, what we're seeing is it's typically more useful for smaller tasks that you're more confident that you can delegate reliably, whereas local is when you want to be a little bit closer to the agent. It's maybe some larger task or some more complicated task that you're going to kind of actively be monitoring, and you want it to be local so that if something goes wrong, you don't need to pull that branch back down and then start working on it, but instead you're right there to guide it.
Yeah.
Yeah, maybe I'm just greedy, but I want both. And I think having a modality, to Matan's point, where I like to think about what are the primary forms of collaboration that I'm used to and I enjoy with my coworkers. Often that starts something like a whiteboarding session, and maybe we're just like jamming on something in a room. When we were building, I think a good example was agents.md, which is our kind of custom instructions intended to be generic across different coding agents. The way that started was Romain and I were just in a room coming up with this idea, and then we just started whiteboarding and then took a photo and then kicked it off in Codex CLI locally, just to kind of workshop a Nextjs app that we could work on. Went to lunch, came back. So having that kind of pairing and kind of brainstorm style experience, and then I think to that second point about what kind of tasks you delegate to, I think historically smaller, more narrowly scoped tasks where you're very clear about what the output is kind of the right modality if you're doing a fire and forget. But I think what we're starting to see with, we just launched GPT-5 Codex about 2 months ago now, and I think one of the main differences is that it can actually do these longer running, more complex, more ambiguous tasks, as long as you are clear about what you want by the end. So it can work for hours at a time. I think that shift as models increase in capability will start to enable more kind of use cases.
Yeah, I think there are 3 parts of making an agent work. There's the actual agent loop, there are the tool calls it makes, and then the resources upon which the tool calls need to act. Whether you go cloud or local first is based on where those resources are, right? If you're trying to work on a local file system, those are the resources you need to access. It totally makes sense that your agent loop should run locally, right? If you're accessing resources that typically exist in the cloud, you're pulling from GitHub, directly from like third-party repo of some kind, then it makes sense for your agent to start off in the cloud, right? Ultimately, though, these resources exist in both places, right? Every developer expects an agent to be able to work both on the local file system as well as on an open PR that might be hosted on GitHub. And so it doesn't really matter where you start, I think. Everyone is converging at the same place, which is that your agent loop needs to be able to run anywhere. Your tool calls need to be able to be streamed from the cloud locally or from the local back up to the cloud. And then it all depends on where the resources you actually want to act on are located.
Yeah, awesome. Okay, so we were chatting off stage, and we were like casting around for spicy questions and stuff. So I really like this one, and I think it's very topical. Do you guys generate slop as a living? Like, are we in danger of potentially being in a hype bubble where we believe that this is like a sustainable path to AGI?
I mean, I think to start, you could say that one man's slop is another man's treasure, which to some extent might be true. If, for example, you have, I don't know, like let's suppose you had a repo that had no documentation whatsoever. Okay. You could use, many of the tools that we've been talking about to go and generate documentation for this repo. Now, is it going to be the most like finely crafted piece of documentation? No. But is it providing alpha? yes, in my mind, because having to like sift through some super old legacy code base that has no docs is a lot harder than looking through some somewhat slopified documentation. And so I think the big thing is it's figuring out where you can use these tools for leverage, and the degree to which it's slop, I think also kind of depends on how much guidance you provide. So if you just say like, build me an app that does this, like you're probably going to get some generic slop app that does.
It's purple.
Yeah, that's blue, purple,
gradient.
like fade. Yeah. Whereas if instead you're like very methodical about exactly what it is that you want, you provided the tools to actually run tests to verify some of the capabilities that you're requesting, I think that makes it much more structured to a similar extent that if you were to, hire some junior engineer onto your team and you just say, hey, go do this. Like they're probably going to yield some like median outcome because they have no other specification to go off of. And it's pretty ambiguous, like what you actually want done.
I think the keyword there is leverage, right? Like what AI coding agents allow you to do is do 10x more than you would be able to do yourself with a pretty high floor, right? So if you plot skill level against how useful an agent is or how likely it is, how useful it actually is in generating non-slop, there's probably a like pretty low floor. If you have no skill, you have a pretty high floor still, right? Agents are pretty good just out of the box. If you don't know anything about development, the agent is going to do much more than you could possibly do. But as you get to higher and higher skill levels, senior and principal and distinguished engineers actually use agents differently. They're using it to level up the things they could already do. A principal engineer might be able to write manually 5,000 lines of code a day. With agents, they can write like 50,000 lines of code a day. And it really operates at the level of quality of the inputs and the knowledge that you put in there. So I think we're slowly raising the floor over time by building better agents. But I do think it's a form of leverage. It's a way for you to accelerate the kinds of things you can already do them faster. And for folks who don't have skills, that's when you can actually really raise the floor of what it can be do.
Absolutely. And just to add on to both of these points, I think they're tools and amplifiers of craft. If you have it, you can do more of it. If you don't, it is just harder, but it does raise the floor. I think that's really worth calling out. I think for folks who are just trying to build their first prototype, they're trying to iterate on an idea. That example I was mentioning earlier, it's not that I couldn't make a front end that kind of is like a content-driven site, but I just didn't have time, and it was more fun to just draw on a whiteboard, have a conversation, and then kick that off to an agent. But I think one of the interesting examples of this was when we were building much earlier iterations of Codex well over a year ago, and we were putting in front of two different archetypes, folks who did a lot of kind of product engineering where they're used to using kind of local in the inner loop style tools where they're used to just chatting and maybe iterating. And then a completely different modality when we talk to folks on the reasoning teams where they would sit for maybe 5 minutes just defining the task and have like an essay length like word problem for the agent to go off and do, and then it would work for an hour. And that was effectively 01 or earlier kind of versions of it. And I think the interesting part there was just the way that people would approach giving the task to the agent was completely different based on their understanding of what do they think it needs. And so I think really anchoring on specificity, being really clear about what you want the output to be. And then I think there's a broader item that is a responsibility on both us as builders of agents and folks training models to really raise that floor and to ensure that the ceiling for people with high craftsmanship, with high taste, are able to exercise that in the way that they see fit.
I think actually something that you mentioned brought this idea to mind that we've started to notice. So our like target audience is the enterprise. And something that we've seen occur time and again is that there's a very interesting bimodality in terms of adoption of agent native development. And in particular, normally earlier in career developers are more open-minded to start building in an agent native way, but they don't have the experience of managing engineering teams. So they're maybe not the most familiar with delegation in a way that works very well. Meanwhile, more experienced engineers have a lot of experience delegating. They know that, hey, if I don't specify these exact things, it won't get done. And so they're really good at like writing out that paragraph, but they're pretty stubborn and they actually don't want to, change the way that they build. And you're going to have to, pry Emacs out of their cold dead hands. So it's an interesting balance there.
So funny you say that. Similar thing we've seen on the enterprise is, senior engineers, higher up folks will write tickets. So they'll actually do the work of like writing out all the spec of what needs to be done. They'll hand it off to a junior engineer to actually do. The junior engineer takes that super well-written ticket and gives it to the agent to do, right? So you're just arbitraging the idea that the junior engineer will actually do the agent work because they're more comfortable doing that. But the senior engineer is the person who's actually really good at writing the spec, very good at understanding like what are the architectural decisions we should be making, and putting that into some kind of ticket.
Yeah. For those who don't know, Matan and Factory in general have been writing and advocating about the agent native development, so you can read more on their website. I think one thing, by the way, I do want to issue maybe like one terminology thing, which is raise the floor for you is a good thing. But I think actually other people say lower the floor and also mean the same thing. Just like it's about skill level and like what they can do, and just giving people more resources for that. I think also the other thing is like a lot of people are thinking about the model layer, right? Obviously, you guys own your own models. The two of you don't. And I think there's a hot topic of conversation in the Valley right now. Airbnb, Brian Chesky has said that like most of the Valley is like relies on Quen apparently. How important is open models to you guys? And you can Fuad, you can chime in as well. But like, how important is open models like, as a strategy for both of you?
I'd be curious to hear from you first.
Yeah.
Well, love open models. I think one of the important things about so just before we talk about
OpenAI has
models,
an
I think
open model.
openness is really key to I think a sustainable development lifecycle where with Codex CLI we open sourced it out the gate, and part of the priority was understanding that an open model was coming down the line. We wanted to make sure that we could as best document how to use our reasoning models. We saw a lot of
At this point,
confusion about what kind of
should
tools
have
to give
their
it,
own
what the
model.
environment should be, the resources. And so we want to make sure that that was as clear as possible, and then also make sure that it worked well with open
Maybe for
models. So I think
V0.
there are definitely a lot of use cases, especially when you get into kind of embedded use cases or where cases where you don't want the data to leave the perimeter. There's a lot of really good reasons for why you would want to do that. And then I think the benefit of kind of cloud-hosted models, and that's what we see with a lot of open models, they end up being, they're not run on device, but they're actually cloud-hosted anyway, maybe for efficiency, maybe for cost, there's still a lot of value in just the pure intelligence that you get from using a much bigger model. And that's why we see people really gravitate towards models from O3 to GPT-5 to GPT-5 codecs. There's still a lot of value in that. Now we see that overhang still comes, it resolves itself where every couple
see if I can show it over here.
months, there's a new, very small, very, very impressive model. And that's the magic of you just consider the beginning of this year. We had O3 Mini as kind of the frontier and where we are now. And so, yeah, I think that there's a ton of value in open models, but still, I think personally, from a usage perspective, more value in using the kind of cloud-hosted ones.
That makes a lot of sense. I think.
Yeah, I'll just interject a bit.
Using
Fuad actually cares a lot about
using open models. Right, basically
privacy, security, agent robustness, and so you
Definitely
can if you
gonna
run into him,
have
talk to him
their
about more
downsides,
about that.
I think.
But for both of you guys, maybe you want to start off with like actually like what's your ballpark of open model token percentage generated in your respective apps, and is it going to go up or down?
So I guess so maybe to start, because I think what you said is really interesting. So a couple of weeks ago when we released our factory CLI tool, people were really interested because we also released with it our score on this benchmark called Terminal Bench. And one of the first asks was, can you guys put open source models to the test? Because our Droid agent is fully model agnostic. So immediately people were like, throw in the open source models and like show us how it does. And I think something that was particularly surprising was that the open source models, and in particular GLM, were really, really good. They were in fact like obviously less performant than the frontier models, but
Obviously.
not by a huge margin. I think, so one thing that was noteworthy though, was when we benchmarked the open source models, of the 7 that were at the top, one of them was made in the United States by yours truly over here, which I think is kind of a shame.
Yeah.
Like the fact that by far all of the frontier models, it's, you know, United States across the board. But then when it comes to open source, we're really dropping the ball there. So I think that's one thing that's noteworthy, and I think something that, at least when I saw that, I really think there should be like a call to arms there in terms of changing that. Because I think to answer your question, what we found is that since we released support for open source models, the percent of people that are using open source models has dramatically risen, partially because of cost, and that, you know, it's allows you, like, let's say in that documentation example, maybe you want to generate docs, but you don't want it to be like, you know, on super high reasoning, like to the max, like cost you $1,000, but you just want to get like some initial first pass in. And also people like having a little bit more control, and I feel like they get a lot more of that control with some of these open source models, both controlling the cost and just like kind of observability into what's actually happening there. So I think the demand has grown to a point where I actually did not expect a year ago. I think a year ago I was less bullish on open source models than I am now. Open weight, but yeah.
Yeah, I think we use both open source and closed source models in our overall agent pipeline. And I think the way we think about them is there's 2 different use cases for an LLM call. One is you want state-of-the-art reasoning. It's a very, very open-ended question. You actually don't know what the answer is. The goal function is not super well defined. In those cases, closed source models are still state-of-the-art when it comes to reasoning and intelligence. We use closed source models pretty much exclusively for those kinds of use cases. There's a second use case where we have a more niche task with a much clearer goal function. And in those cases, we almost always try to fine tune an open source model. We're okay taking a 20% cut hit maybe in terms of reasoning ability, so that we can actually fine tune a very, very specific use case. And I think we found that open source models are catching up very, very, very fast. A year and a half ago, it was like unthinkable for us to be able to use open source models as part of V0's pipeline. Today, every single part of the pipeline, we're like, okay, can we bring open source models into this? Can we, replace what we're doing currently with closed source state-of-the-art frontier models with a fine tune of an open source model? And we've seen a ton of success with Quen, Kimi K2, other kinds of models like that.
Yeah. I'll call this out as one of the biggest deltas I'm seeing across everyone, which is at the start of this year, I did a podcast with Ankur from Brain Trust, and he said that open source model usage is roughly 5% across what Brain Trust is seeing and going down. And now I think like reasonably it's going to go to like between like the 10 to 20% range for everybody.
I do think it's interesting that even closed source models are investing more heavily into their small class models, right? The Haikus, GPT-5 minis, Gemini flashes of the world, which I think also is like that model class is what competes with open source the most.
Gemini
it's
Flash,
the small model class competing against a fine tune of an open source model.
And I also think there's some use cases
Gemini
where it's
Flash
just
is actually
it will just be overkill to use a frontier model, and if it is
Gemini
overkill,
2.5.
you are then just going to obviously be incentivized to use something that's faster and cheaper. And I think part of I think this delta in terms of percent usage is like there is this threshold of like when open models cross the threshold of like for most tasks it's actually enough, and then for some niche tasks you need like the extra firepower. I think we're really getting there with some of these open models, which is why I would suspect we'll see more usage going forward.
Yeah, awesome. That's very encouraging. So we have a bit of time left. I prepped you guys with the closing question, which is what's something that your agents cannot do today that you wish they could do that they'll probably do it next year?
Am I going first? Okay. Yeah, I think that what we've seen over the last year, just maybe starting as a reference point, with O1 a little over a year ago, or O1 preview, what we've seen from then when I was using very early checkpoints of that model, it was great relative to 4.0. but still had so much left to be desired. I wouldn't put it. I was on team at the time, and there was a lot of work and tasks that I just couldn't delegate to that model. And when we compare it to today, where I can take a pretty well-defined task, like maybe it's like 2 sentences, a few bullet points, to your point, like here are the gotchas that I think you'll probably get stuck on, and then come back and 30 minutes later, an hour later, it's done it. We've seen cases where it's running for many hours, maybe even 7 to 8 hours, effectively a full workday that I spend a lot of my day in meetings, and so don't necessarily have that kind of solid block of time. But that's only half of what engineering is really about. Part of it is coding, part of it is architecting and troubleshooting and debugging. The other half of the problem is writing docs, is understanding the system, convincing people. And so I think what we'll start to see is this kind of super collaborator where what we want to bring, whether it's in Codex or these other kind of interfaces through the Codex model, is the ideal collaborator that you want to work with, the person you first go to, that favorite coworker that you want to kind of jam on ideas with. That's really what we want to see with, at least with Codex.
For us, we've seen a bunch rapid progression on 2 different fronts. The first is how many steps can you reasonably expect an agent to be able to do and get reasonably good output? Last year, there's probably 1, maybe max 3, right? If you wanted reliable output with over 90% success, you're probably running 1 to 3 agent steps. Today, most tools run 5 to 20 with no really great reliability rates, over 90% success. I think next year we're going to enter the like 100 plus, 200 plus. Let's run tons of steps all at once, have long running tasks for multiple hours, and be confident that you'll get an output at the end that will be useful. The second is in terms of what resources can be consumed. A year ago, it was whatever you are putting into the prompt form. Like that was pretty much it. Today, you can now configure external connections, via MCP or by, making API calls directly in your application. You can kind of do that if you're knowledgeable, you have the ability to configure things. And I think in a year from now, those will just happen. Like it will just work. The goal is like you should not need to know what sources of context you need to give the agent. The agent will actually go and find those sources of context proactively. We're kind of starting to see that already today, but I'm still not really confident that's very reliable and useful today. I think by next year, that'll be the default mode.
Yeah, I would agree with that. I think agents can do basically everything today, but the degree to which they do so reliably and proactively is, I think, the slider that is going to change. But that's a slider that's also dependent on the user. Like if you're a user who's like not really like changing your behavior and meeting the agent where it is, then you might get lower reliability and proactivity. Whereas if you kind of set up your harness correctly or set up your environment correctly, it'll be able to do more of that reliably and more proactively.
Yeah, amazing. Well, we're out of time. My contribution is computer vision. Everyone try Atlas. Everyone try like more computer vision use cases. But thank you so much for your time.
Thank you.
Thank you for having us.
Amazing. I actually want to hear an announcement on ChatCN. I think they should have an announcement or something. Hopefully. I think we'll have to move over to the actual site. So we're currently still on. Let me quickly share my screen and see if I can show you guys this. What I'm seeing right now. Let's see. How can I share my screen over here? I don't know how to do this. Interesting. Entire screen, vessel shape. Oh fuck. Okay. Let's see this. Okay, so we've gone through I think the keynotes. Um, we have to quickly switch over to watch the continuation. I think we've gone through um keynotes. Okay, broadcast has ended. So I think we quickly have to switch over to the actual site. Vessel.ship. Let me quickly just try to log in here. Um, and we should be able to. This might take just a minute. My camera is off actually. Okay. So let's just to complete purchase. Um, okay. So they ended the broadcast on Twitter or X. So we quickly have to get the actual link. I think I just got the notification. So we're switching over now. Stream. Uh, I already have a ticket. I should be able to schedule. Um, okay, so I should be able to schedule and watch this live directly. So let's look at. Um, I think let me check. Let me check YouTube to see if these guys are showing on if they are live streaming this on YouTube. Um, Vessel, come on, what's going on? I need this URL, direct URL to watch this shit. It's today Wednesday. It is actually Wednesday. It's a lie. Oh no. Oh, interesting. Um, what's today Wednesday? I can't believe it. Vessel. Nextjs. I don't know if you're just joining this live stream right now. I'm still trying to get the actual link. They stopped streaming on X. Um, and I don't know why. I think they want to go into different stages. So we have to watch a particular stage at this point. Let me even look at the schedule again. So we have um opening keynotes. We've gone through that one, right? Then we had a panel recently talking about AI. I'm trying to look for that particular panel. Where did they? Are they actually following this schedule? Interesting. Because they did a panel with OpenAI team, the V0 team, then one other AI company. Let's see. Man, where's the actual link? Russell, where can we get the link? Uh, let me go to Twitter again and check. Um, looking at. Oh, okay. We're looking at vessel. We're looking at vessel ship. Vessel ship AI is tomorrow, right? And what we're currently watching is the Nextjs Conf. Yeah, I was like, what's going on? We don't. Oh, that makes sense. Okay, I think we actually figured it out. Yeah, this should be the actual link. Are they showing it on YouTube? Can we watch it on YouTube? Um, this error is actually coming from the team. They told us to go to the wrong URL. That's bad. Well, let's see. Let's see if they are live on YouTube. Because vessel ship, I think vessel ship is supposed to happen to. Aha, there we are. I don't think you guys can hear this. I don't know if um I don't think there's sound in this. Okay, so it says um I need to share my screen again for you guys to hear the sound. Yeah. I think it's better now. Okay, so I think this is the right URL. So we've gone through feature section. I need to look at the full schedule. So looking at the full schedule, we have the open keynotes. Um, we've gone through the open keynotes, coding for the feature. Yeah, this was what I was actually talking about this, right? Conversel, OpenAI, latent space. Um, we're currently on a break. I think a 15 minutes break or 20 minutes. I think this is 25 minutes break. Um, 25 minutes, 30 minutes break. I don't know. In between those two. Then once they are back from the break, we'll quickly just look at composition, caching, and architecture in modern JS. Okay, amazing. We pretty much have um, a long lineup, and let's quickly take a look at the time. What's the time right now? Because I actually don't look at time. This is okay. I think this is San Francisco. Let's look at SF time right now. What's the time at SF? This is 10:38. Yeah. This is 10:38 SF. So we still have like up to 20 minutes more, approximately 20 minutes more for the start. Yeah, I think we'll be back. We'll be back once once they are back from the break. Um, let me look at this lineup again. I'm looking forward to something about Shatsi. Um, oh, we have something talking about Trobo. Is it Trobo Pack? Very interesting. Design engineering launch. Huh. Oh, this is so amazing. Like you just need to be as SF like right now to actually enjoy this show. Oh shit. Can you guys still hear me? Hi Obabo. Thanks for joining the live stream. I don't know if you can hear me actually. Can you hear me? Hi. Ay, 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 ay. Okay, so we'll be back in the next 10 minutes, right? Next 20 minutes, 10 minutes approximately, to continue the watch party for Next.js. Um, they're currently on break. We are currently at this point, right? This is full schedule. I don't know if let me drop a link for people that want to take a look. Um, I doubt I'm still live. Am I still live? I don't know. But I'll be back though. I'll drop a link for people that want to take a look. Um, and we'll be back. We'll be back by what's the time now? Just to confirm again. We're back in 5 minutes time, 10 minutes time. Yeah. And and I need to confirm if I'm still live. Okay.
Please welcome to the stage Crayon Consulting web developer Aurora Scharf.
Okay, hello everyone. My name is Aurora. I'm a web developer from Norway. I work as a consultant at Crane Consulting in Oslo, and I'm actively building with the Nextjs app router in my current consultancy project. Today, I'm going to be teaching you patterns regarding composition, caching, and architecture in modern Nextjs that will help you ensure scalability and performance.
Amazing.
Let me first refresh the most fundamental concept for this talk: static and dynamic rendering. We encounter them both in the Nextjs app router. Static rendering allows us to build faster websites because pre-rendered content can be cached and globally distributed, ensuring users can access it quicker. For example, the Nextjs Conf website. Static rendering reduces server load because content does not have to be generated for each user request. Pre-rendered content is also easier for search engine crawlers to index, as the content is already available on page load. Dynamic rendering, on the other hand, allows our application to display real-time or frequently updated data. It also enables us to serve personalized content, such as dashboards and user profiles. For example, the result dashboard. With dynamic rendering, we can access information that can only be known at request time. In this case, which user is accessing their dashboard, which is me. There are certain APIs that can cause a page to dynamically render. Usage of the params and search params props that are passed to pages or their equivalent hooks will cause dynamic rendering. However, with params, we can predefine a set of pre-rendered pages using generate static params, and we can also cache the pages as they're being generated by users. Furthermore, reading incoming request cookies and headers will opt the page into dynamic rendering. Unlike with params, though, trying to cache or pre-render anything using headers or cookies will throw errors during build, because that information cannot be known ahead of time. Lastly, using fetch with a data cache configuration no store will also force dynamic rendering. So these are the few, there are a few more APIs that can cause dynamic rendering, but these are the ones we most commonly encounter. In previous versions of Next, a page would be rendered either as fully static or fully dynamic. One single dynamic API on a page would opt the whole page into dynamic rendering. For example, doing a simple auth check for the value of a cookie. By utilizing React Server components with suspense, we can stream in dynamic content like a personalized welcome banner or recommendations as they become ready, and provide only fallbacks with suspense, while showing static content like a newsletter. However, once we add in multiple async components on a dynamic page, like a feature product, they too would run at request time, even though they didn't depend on dynamic APIs. So to avoid blocking the initial page load, we would suspend and stream those components down as well, doing extra work, creating skeletons, and worrying about things like cumulative layout shift. However, pages are often a mix of static and dynamic content. For example, an e-commerce app, dependent on user information while still containing mostly static data. Being forced to pick between them, between static or dynamic, causes lots of redundant processing on the server, on content that never or very rarely changes, and isn't optimal for performance. So to solve this problem, at last year's Nextjs Conf, the use cache directive was announced. And this year, as we saw in the keynote, it's available in Nextjs 16. So with use cache, pages will no longer be forced into either static or dynamic rendering. They can be both. And Nextjs no longer has to guess what a page is based on whether it accesses things like params. Everything is dynamic by default, and use cache lets us explicitly opt into caching. Use cache enables composable caching. We can mark either a page, a React component, or a function as cacheable. Here, we can actually cache the feature products component because it does not need request time processing and does not use dynamic APIs. And these cache segments can further be pre-rendered and included as a part of the static shell with partial pre-rendering, meaning the feature products is now available on page load and does not need to be streamed. So now that we have this important background knowledge, let's do a demo, an improvement of a code base with common issues often encountered in Nextjs apps. These include deep prop drilling, making it hard to maintain or refactor features, redundant client-side JavaScript, and large components with multiple responsibilities, and lack of static rendering, leading to additional server costs and degraded performance. So yeah, let's begin. And give me one sec over here.
Okay, we're getting a live demo. Amazing. I always enjoy live demos. Anything
All
could
right.
go wrong.
Great. So this is a very simple application. It's like inspired by an e-commerce platform. And let me do like an initial demos here. So I can load this page. I have like some content like this feature product. I have feature categories, different product data. There's also this browse all page over here where I can see all of the products in the platform and page between them. Then we have this about page over here, which is just static. I can also sign in as a user, and that will log me into my user, and also get then personalized content on my dashboard here, like, for example, recommended products or this personalized discounts here. So notice here, there's a pretty good mix. Also, one more page that I forgot to show you. The product page, the most important one. Also here, we can see product information and then save it if we like for our user. So notice that there's a pretty good mix here of static and dynamic content in this app because of all of our user-dependent features. Let's also have a look at the code, which would be over here. So I'm using the app router here, of course, in Nextjs 16. I have all of my different pages, like the About page, the All page, product page. I also have, I'm using feature slicing here to keep my app folder clean. I have like different components and queries talking to my database with Prisma. So yeah, and I purposely slowed all of this down. So that's why we have these really long loading states, just so we can easier see what's happening. So the common issues that we wanted to work on here that we actually have in this application was deep prop drilling, making it hard to maintain and refactor features, excess client-side JavaScript, and lack of static rendering.
Hello, New Rockstars. I'm Eric Voss.
And I'm Jessica Clemens.
We've got some big news. New Rock